Hello everyone, welcome back to this channel, and in this tutorial this is going to be our first major data science project, and we are going to learn a set of or apply the set of skills that we learned in the previous tutorials to tackle a business problem. And the hope is that at the end of this tutorial you will be able to kind of have got the intuitive on how data science or analytics is used to make informed business decisions and evidence-proved data or evidence-proved solutions in business environment. So to get that started, I've provided you with a data set of employees in a company. For the sake of privacy, we are going to call this company X, and this is a real set of data. So think of it as a problem that you have been given by your boss in a business environment, and they've asked you to look at this data and help them with a business intelligence decision or give them a decision in the organization. So the assumption is that you are part of the organization and you are the data scientist or analyst in that organization, and therefore you are going to use the provided data by the human resource department to help them solve a problem. So the problem is straightforward. There's two data sets, and these two data sets are contained in an Excel spreadsheet. The first spreadsheet contains the data set of all the existing employees of the company, and then the second sheet of the spreadsheet contains a data set about the employees who have left the company. And this data contains several or around 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So it contains 10 attributes about these employees. The first attributes contain the employee ID. So this is a unique key to every employee. The second one contains the satisfaction level, which is graded from 0 to 1, and with 0 meaning the lowest satisfaction level and 1 the highest satisfaction level. The next attribute is the scores for the last evaluation, and also graded from 0 to 1, with 0 the least, 1 the highest. And then a ranking of senior or major projects that each of these employees have undertaken, and there are a set of integers that accounts for the number of major projects that each of the individual employees have taken. And then the third one is the average number of hours they have worked in a month. The fourth one is the time they have spent in the company in terms of years. So the units for that is years. And then the other one is the number of accidents they have participated. So this is a very categorical data point. It's either 1 or 0. 1 to mean they have incurred accident at work, 0 to mean they haven't incurred accident at work. The other one is also the promotion for the last 5 years. So 0 to mean those who have been promoted, and 1 to mean those who haven't been promoted. And then the other one is the department of each of those employees. There are several departments. There's sales, accounting, human resource, technical support, management, etc. And then the last one is the salary that each of these employees have earned, or their salary classified as either low, medium, or high. So that is the brief description of the data set, and your problem or your work is to use this data set to answer two business questions. And these two business questions, the first question is, what type of employees are leaving? So you're going to use the data set that have been provided. So you have got two data sets, the existing employees and the employees that have left. So your work as the data analyst or scientist in this case is to tell the human resource what kind of employees are leaving, so that maybe they can avoid it, or they have better understanding of why their employees are leaving. That is the first business question. The second business question is, which employees are prone or are likely to leave in the next, or out of these existing employees, what kind of employees are likely to leave? So by analyzing the employees that have left you can easily tell the employees that are likely to leave. So with this, it's going to be a very interesting and more realistic projects that will get us understand and apply the techniques that we have been learning through to this and come up with a solution that actually solves a business problem. So let us get started. As is the custom, we need to import the necessary libraries that we are going to use for this project. The first library that you're going to import is pandas. So import pandas. And this is basically to allow us to manipulate the dataset because it's in tabular form. We import it as PD. The next library that we need to import is a matplotlib for plotting. .py plot as plt. And then the last one is seaborn, because you learn that seaborn is very, very crucial when it comes to plotting of datasets, SNS. And then lastly, we want to have our graphics within the cells. So I can say matplotlib inline, just in case we want to plot any graph within the cells. So let's make this neat and say what we are doing for each cell. So I'm going to try, because at the end of the day, you're going to prepare a report to your senior who has assigned you this task. And through your code and explaining each of this section, you can actually generate a report from this, your code. So first of all, let us define what we are doing. First, import the necessary libraries to be used here. So the next thing is to read the Excel file and convert it into a data frame. So this one should be a markdown, not a code, to tell whoever have access to your code to understand what you are doing. So we normally assign it a variable df and then pd.read. Since this is an Excel file, we use pd.read Excel and then have the input of the file. So the file name is employee data.xlsx. So let's do that. We input this as a string, employees .xlsx. That is the file format for spreadsheet. And then we're going to look at those employees that are leaving, because that is our first objective. So the name of the sheet that contains the employees who are leaving is named as employees who have left. If it was sheet 2, maybe that is the name. So we're going to specify that when importing here as the name of the sheet. Sorry, I copied it from let me copy this. I've copied. I hope it's gonna copy correctly. Yes. And of course, as is the custom, let us display the first 5 data points to see that we have correctly imported our file. So we run this, and yes, it has imported. You can confirm each of the attributes that are given are shown here. So the first thing is just to define our business question here within our code. You can do this if you like. If you don't like, it's fine. It's just part of documentation. So we can say business. And the purpose to save us time, I pre-typed this so that the video doesn't take a long time me typing words. So this is our business question. You can type it. Feel free to pause the video and type it. Now, let's start with the basics. So the ones what you need to get us started. Let's just do a quick, I will call them data inspection. So let's just inspect our data. So the first thing we need to know is how many data points do we have, and you remember use df.shape, and that will tell us we have 3,571 data points and 10 attributes or features. So the attributes are column names, and then we have got 3,571. So it means the total number of employees who have left are 3,571. We can confirm this by doing df.tail and look at the index to see if we can see the same number is 3,570. Of course, the first number was 0, so that's why we are not having 3,571, but 3,570. So a total of 3,570 employees have left. Also, we can have the column names to just know how many number of columns do we have. Sometimes your data might have more than 10 or even 100 columns. So it's very, very important to do this so that you know the number of columns. Of course, you have got each of these columns that I described previously. So obviously, this is not a prediction problem, and therefore the employee ID or the unique ID is not required. So we can straight away drop it. So to drop it, we just use the name of the data frame, which is df, and then use the function, pandas function called drop. And then inside this function, we specify the column that you want to drop. The column that you want to drop, you normally want to copy it because of white spaces, to avoid these white spaces. So for example, we have a white space here. So let us copy it so that we don't mess with the column name. So that is the column that you want to drop. And then just ensure that our axes are still making sense by specifying it as 1. And let's confirm that we have indeed dropped the column name. So we have already dropped it. You can see it's no longer there. So these are the columns that you are going to consider for this analysis. Again, another preliminary check that you want to do is a check for missing. So in your data science journey, if you encounter missing data, there are always different ways to solve it. If it's a categorical data set like this, you might use mod to solve missing data. In other words, you use the most common one to impute or replace the missing values in a data frame. If it's a numerical value that is stretched within a certain interval, then you might use the mean. And then in some cases, you might just want to drop any missing value. So those are some of the options that are available for you. Dropping is always the easiest, but sometimes you might have got a lot of missing data points, such that if you drop it, you might end up from maybe 1,000 data points, you end up with maybe 100 data points, and that is not good. So in most cases, you want to find a way to handle missing data. So in this case, we can check the missing data by using the isNull function of pandas. And it's very straightforward. You just type the name of the data frame, and then you type the function name isNull with brackets. And this will tell us whether there's any data point. So you can see that it says that false. It means none of these data points have any missing values. So this statement is not true for each of these data points. But it's very hard to tell because there are some data points that have been hidden simply because we cannot display the whole of our data frame in our notebook right now. So an easy way to do this is sometimes to write a loop, or we can just, first of all, let me show you how to check for every single column if there's any missing value. So let's start with satisfaction level, and I want us to create a variable name called sat level. And this will simply check if there's any missing value in our data frame, which is df, and specifically within the column name called satisfaction level. And once we run this, we simply run it calling the variable name and then run it. So you can see it's completely 0, meaning that there's no missing value in this column called satisfaction level. Otherwise, if there were missing values, it could have returned some kind of a data frame. You can do the same for evaluation, number of project, average monthly hours, time spent, work accident, promotion in the last 5 years, department, and salary. So to do that for every column might be tedious by typing this repetitively. And remember, I always have this cardinal rule in Python that if you are doing something more than 4 times, then probably you need to use a loop. If you're doing something the same more than 4 times, then you want to use a loop. So for the purpose of this video, and this is a learning video, I will show you how you can write a loop to iterate through each of those columns and check if there's any missing values, so that you can use that loop for whatever data you are given at your work, at your research, at your school, or whatever you are working on analytics projects. So to write, so let me just say create a loop to check through all columns. So I'm just trying to document this code so that it looks nicely. I'm going to post it on my GitHub account so that you can check it and run it on your own, or use it as a template for replicating this project. So first of all, let's create a list that contains each of these column names, and then we're going to loop through each of those column names to check if there's a missing value. So it's a very straightforward code. I'm going to guide you to do that. So let's create a list called attributes. By the way, these column names can be called attributes. In machine learning language, we normally call them features. They basically describe the data set, and each of these individual points are called data points in machine learning language. Okay, so let's create a list that contains each of the individual column names, and to do that I'll just copy it from my column names here, because I can do it. It's very straightforward rather than typing each one of them, and paste it inside this list. And normally before I run my loop, I normally just run the basic one to check if the loop is working. So I can say for attribute, and the word attribute can be anything. Remember from our introduction to Python, now you appreciate that each of those tutorials that we learn are now beginning to piece together in a project like this to come up with a finished product that actually answers a real life situation. So in attribute, which is the name of the column, and best practices in Python, you skip a line after typing a for loop, and then let me give it create a variable name called null check to check if there's null values. And we simply use this syntax here that I showed you earlier, pd.isNull, and the name of the data frame, which is df. But now we are checking through each of these column names, which have given a variable or a holder called attribute. So I'm going to copy this attribute here to look for each of those elements or each of those items within our list. And for the purpose of this video, let me just print null check. Okay, so it returns each one whether it's false or true, and you can see how that goes. So we can print for the data frame itself by simply doing same approach here. So in our case, sat level will be the null check, and then the df, the df is going to be the same, so which is just our data frame, df square bracket, and then null check, and then it will show us if it will show us all the missing values in each of the columns. So let's run this. So now it returns the data frame with missing columns if there's any. Otherwise, if there's none, it will simply return an empty data frame. And you can see it has told you there's an empty data frame for the case of satisfaction level, which is the first one. Second one, last evaluation. So all of them have empty empty data points, meaning that there's no missing values. So probably this data set was cleaned before you were given. So that is what my suspicion is, because it's very hard to find error-free data or data sets that are completely filled with no missing values. So now that we have confirmed that there's no missing values, we can proceed with our application or our exploration. So this next part now is data exploration. So let me write or introduce it as a new heading. So remember, we are still exploring this data to ensure that we answer those business questions. So the end goal is to come up with the answer to our business question. And for those who might have forgotten or along the way, remember the two business question is, what type of employees are leaving? So let me just have them or enumerate them. And then the second one is, which employees are likely to leave next. So those are the two key business questions that we are answering with all this analysis that we are doing. So the first thing that I normally find very, very useful when we are approaching or handling data analytics, data science project is having a correlation heat map. So correlation will give you, and I think we did this in one of our last videos about correlation. So correlation is a very, very fundamental concept in statistics that is very, very useful when analyzing data sets. And it refers to the statistical measure by quantifying the relationship between two or more variables. So in this case, our variables are each of these columns. So this is a variable in itself or a feature. This is another variable. This is another variable. This another variable. All of these are variables. So if we compare, let's say, satisfaction level to last evaluation, it will give us some kind of correlation, if there's any correlation. That means if they're related. Remember, relation doesn't mean that there's some cause or one causes the other. No, it just means that maybe if this value is increasing, then this one is also increasing, or if this value is decreasing, this one is decreasing, or if this one is increasing, this one is decreasing, and if this one is increasing, this one is decreasing. So those are some kinds of combinations that might exist, and you can do that for all the data sets using the function of Seaborn known as heatmap. But let us understand that correlation simply tells us or helps us understand the changes in one variable with the other variable. So it doesn't imply causation. In other words, if one variable is increasing and the other one is increasing, it doesn't mean that the first one is responsible for the other one. For example, if you compare the number of projects and the average monthly hours, and from the correlation you see that the number of projects increases as the number of monthly hours increases, it doesn't necessarily mean that the number of projects is responsible for the average monthly hours. And this is why it's very, very important to have subject matter experts when you are doing a data analysis or data science project for an area that you are not a specialist in. So that is why in most departments you will find a team composed of multidisciplinary individuals to give you those kind of intrinsics or the subject matter opinion when you are doing your analysis. So correlation is not causation. Very, very important. How do we measure correlation in data science? There are different types of correlation, and the best or the easiest, the most common one is known as the Pearson correlation coefficient, normally denoted by small r. And this basically measures the linear relationship between two continuous variables. So these variables, so it measures the relationship between variables that are linearly related. In other words, ones that increase proportionally. For example, I'll give an example of maybe the income of a person and the type of house they buy. So chances are that, and in most cases is that if the income of a person increases, they are likely to buy more expensive house. So that is a very, very linear relationship. It doesn't necessarily mean that one is causing the other, but in this context, I think one causes the other. However, there might be another play of different factors, but one is causing another. And to measure that relationship, we use a metric, and this metric, the common one that we use for such kind of relationship, is called Pearson correlation coefficient, denoted as small r. It's based from -1 to +1. So -1 to mean it indicates that there's a negative correlation. So negative correlation is that one large value or one large variable results in a small other variable, or one small variable leads to large other variable. So it's inverse proportionality. I will give you a good example. A good example is the case of as the product or the price of goods increase, the number of sales or the sales volume is likely to reduce. Why? Because if it's expensive, less people will buy it. So that is a very good example where there is a negative correlation. Another example where there is a negative correlation could be the case of employment rate. So if employment rate goes up, then chances are that crime rates in an area might go down. And if crime rates goes up, chances are that employment rate has gone down. So those are examples of negative correlation, and they are implied using a negative value. I've talked about negative correlation. I've talked about positive correlation. Positive correlation, large set of values lead to large set of values. Small set of values leads to small set of values. So one variable, as one variable increases, the other one also increases. One variable reduces, the other one also reduces. Perfect case of positive correlation. There's also a correlation of 0. So if you have got a Pearson correlation coefficient of 0, then it indicates there's no relationship between the variables. So they are not correlated, or simply they are uncorrelated. It happens. We're going to see that in this our data set. So let's apply the Pearson's correlation coefficient to understand or see if there's any kind of relationship between these variables. And I think in one of our videos, if you have not watched that video, please go and check on it. I described how to use correlation and specifically display them as heat maps in Seaborn so that you can apply them in your data set. So I'm going to use the same function. If you have not watched it, please go back and watch the video, or else you are still going to learn it here. I'm going to show you how to do it here. So the first thing that I'm going to do in this case, I'm going to increase or simply use the library that will allow us to plot heat map, which is a correlation. So it's going to show a correlation between all these columns of our data set that we have been given and show them as a graph. So we normally use Seaborn. If you can remember, SNS, we have imported this as SNS, and to do that, we'll simply do, so let me just type here, to tell what we are doing. We begin by plotting a correlation heat map. Oh, it's a markdown. And I think I wrote it somewhere. So let me just write this to help you with your understanding. I basically Googled this from ChatGPT. Provide very good information. Again, you can check. Double checked, and the explanation was good. So this is basically generated by ChatGPT, so don't misquote me. You can cite ChatGPT if that works. Yes, so we are going to use the Pearson correlation coefficient, and it's let me make this bold. It's denoted by small r. So now I have explanation of this to help. So now let's use the Seaborn function of heatmap to plot our correlation heat map, specifically the Pearson correlation coefficient. So to do that, I'm going to do SNS, which is the library name, and then use the function heatmap. And then I simply call the name of the data frame that we are plotting, which is a df from our previous, and then use the function corr, which is the function that allows us to do so. And then we annotate to make it true. And then I'm going to use the color map. And I kind of like yellow, green, and blue. Feel free to use other color maps. So I'm going to use yellow, green, and blue. You can use other color maps. There are so many of them. The easiest way, I know it's very dumb to do it, I normally just type a wrong color map and then it will give me a set of options. That's an easy way to do it. So here is our heat map. I think it's too small. We can adjust this by using the matplotlib function plt.figure, and then fig size to specify the size, and then have the column 10 and maybe 6. So this one will increase the size of our plot, yes. So now this is our heat map. So it shows us the correlation between each of these variables using a scale of 0 to 1, of -1 to 1, because this is a Pearson correlation coefficient. I say that Pearson correlation coefficient is based from -1 to 1. And let me just add this very, very important notes here to help you for your future projects, because I know for sure this is not the last of your projects. You're going to be involved in different projects. So let me add these notes to help you along the way. Just explaining or interpreting the Pearson correlation coefficient. -1, that is negative correlation. 0, uncorrelation or no correlation. +1, positive correlation. Okay, with this background information now, we can easily interpret our data, and this is going to be useful when you are writing the report for the senior or to your boss, because now you are using the concept of a concept in data science called the Pearson correlation coefficient to analyze the data that you have been given that maybe people didn't make sense of, but now you are making sense of it and actually going to give very tested and well-proven scientific information that will help the business to know when and why, or what are some of the contributing factors that is leading to the employees departing, and even look at the current data and see if there's a very, very chances that the employee of this category are likely to leave. So let's start basic interpretation of this heat map. In our previous video, I showed you how to interpret it, but now that we are here, I'm going to do that again. While that is happening, please feel free to subscribe to the channel. Give this video a thumbs up like. If you have a question, leave it at the comment as we still pursue and try to get this project going. Now, the first step that we're going to do is to, if you look at our heat map, it has got two scales. Basically, this is our Y scale and this is our X scale, or sorry, not scale, but axis. So the Y axis, X axis, each of them containing the variable names. So remember, the variable names are our column names. Now, how do we interpret this heat map? So we interpret it by comparing the variables to each other or the columns to each other. So if you look at the satisfaction level, it has got a positive correlation with satisfaction level, meaning that there's no correlation between them. They are not correlated. We are basically comparing the same thing. So it's 1. So, sorry, it has got a very strong correlation. Why? And a strong correlation of 1. So it means satisfaction level is strongly related to satisfaction level, which is not useful in this case because it's the same variable. It's not a different variable. So you expect them to be related. Now, let's look at the satisfaction level relationship with the promotion score in the last 5 years. So you can see there's a the Pearson correlation coefficient is 0.005. If you go back to our scale here, we said that a correlation coefficient of 0 indicates no relationship between the variables, and the 1 indicates a positive correlation. I want to add a basic scale here that define will help you again. So this scale is from 0 to 1. Let me just have it as numerics. From 0 to 0.1 is no correlation. Generally. Then, and this is very important, especially even for those people who are into health sector. I know you do a lot of correlation when you're doing drug tests and all those kind of experimental research. From 0.1 to 0.3, it's a low correlation. The next one is 0.3 to 0.5 is a medium correlation. And then the fourth one is 0.5 to 0.7. We have high correlation. And then the last one is 0.7 to 1 is very high correlation. So please use that as a back pocket inference material for this analysis, so that now you can start talking data science based on numbers from your analysis. So with these tools, let's now interpret the table. So satisfaction level, if you compare it with the scores in the promotion scores in the last 5 years, we have 0.055. That falls between here. So no correlation. So that is not an important. We don't need to note that down or make that go into a report. It will be just too much information that doesn't make sense. If you compare satisfaction level with work accident, same 0.0059. It falls under this category. Not much interesting. Satisfaction level with time spent with the company is 0.45. So that falls between this category here, medium correlation. So this is the first note that will go to our report. So the reason why you're writing this is because you're going to write a business report. Remember, in most organizations and even in research, whatever we are doing is like the dirty work. The final product is normally plots and a report. So what goes into the report is based on the work that you are doing here. So this one, you are unlikely to show this to your boss because there might not be even coders. They might not be even understanding the languages that you're using. For them, they just want solutions that are tested and approved with strong or solutions that are anchored on the data that they provided you with. So that is why I'm generating this small text here that will go to the report that you're going to write and present it to your boss. I'm not going to do that. I'm not an excellent expert in project presentation, but I think with these notes that I'm giving you here, all of you, I know you are bright people, you can go ahead and generate a very wonderful report. And please, if you have generated a report, share with me on the comment section, and I will learn from you on how to generate those fantastic reports that can give me a good job and be and not just a data scientist, but somebody who can also make decisions in those boardrooms. Okay, good. That's a by the way. So now we have got an interesting observation here, and this is the work of a data scientist, because you are supposed to make inferences from data. we have got 0.45. It tells us that the correlation is a medium correlation. So let's write that down. A medium correlation of 0.45 exists between a job satisfaction level and the time spent in the company. And the simple explanation is satisfaction level increase or decrease as more time is spent in the company. Remember, it's a positive correlation, so it means that if you spend more time in the company, then the satisfaction level might increase, or equally, if you spend less time in the company, the satisfaction level will decrease. So it's a positive correlation. So that is a key takeaway. We will include that in our report, which we are going to write, by the way. So that is a key point. Let's come to average monthly hours. It has a correlation of negative 0.084. Not interesting. That falls between here. No correlation. 0 to 0.1. Same goes to number of projects. Same goes to last evaluation score. So we are done with satisfaction level in comparison with other variables. Of course, we cannot compare it with the satisfaction level because it's the same thing, and that's why we have got a 1. The next one is last evaluation. So last evaluation score, let us compare it with other variables. So let's start with the scores for the last promotion for the last 5 years. It still falls between this insignificant point, so we leave it. Same goes with accidents. But now when it comes to time spent with the company, it's roughly 0.8 or 0.78. So if you look at it, there is a very high correlation between the time spent in the company and the score of the last evaluation. So again, if we do the same, you can look at last evaluation score compared to average monthly hours. A very strong relationship again, correlation, that is 0.83. And then also the number of projects, 0.8. So let's understand what's happening or what these scores possibly tell us. So let's start with this 0.78. So between the last evaluation score and the time spent in the company. So simply this value of 0.78 tells us that the more you stay in the company, the more your higher score in the last evaluation. That is one option. Another option is the shorter you stay in the company, the less your score in the last evaluation. So I'm going to write those because you're going to write those things in your report, and you can use that as key points or key talking points when you're presenting the output of your work to your boss, so that they see that you are doing. They should not pay you more without you showing that you are really useful in that organization. That's why data scientists are paid more, because they make decisions, or they help senior people make decisions with scientific or statistics from the data set that provided with them. And then that is to do with the last evaluation compared to time spent in the company. Again, we have got a strong correlation of 0.83 when we compare last evaluation with average monthly hours of 0.83. What does that tell us? So what this tells us is the more average monthly hours you work, the more your last evaluation score is likely to be high. That is one option. The second option is the fewer the average monthly hours you work in the company, the less your last evaluation score is going to be. That is this and this. That is average monthly hours and last evaluation. And then the last strong correlation is witnessed between the number of projects and the last evaluation score. So again, what does 0.8 tells us in this case? It can mean two things. The first, the more number of projects that you work on, the higher your last evaluation score is. Or the less the number of projects you have worked in the company, the less your last evaluation score is. So that is key interpretation. Remember, we are not making definite conclusions here because we are still analyzing our data. So now let's make those talking points and add them here. So the next important one is a strong, in fact is 0.8, 0.7 to 0.8. So we can say a very high correlation of 0.8 exists between last evaluation score and time spent in the company. Let's see, what is that? Is 0.78. So let me just have them as brackets because everything is compared to last evaluation score. So time spent in the company is 0.78, 0.78, comma, average monthly hours, average monthly hours. We have that in the bracket too. That is 0.78. Really? 0.83. Sorry, my bad. And number of projects, which is also strong, 0.8. Possible explanations for this, I'll have them as hyphen. I'll hyphenate them. The more you stay in the company, the higher your last evaluation score. That is one option for that, the first one, 0.78. The other option for that is the shorter. We'll just change this. You stay in the company, the lower your last evaluation score. So that is to do with time spent. And then in terms of the average monthly hours is the more average monthly hours accrued, the more or the higher your last evaluation score. And the inverse is true. So the fewer the average monthly hours accrued, the lower and then the last one is in comparison with the number of projects. So we can say the less the number of, or the more, let's start with the positive, the more the number of projects the higher the last evaluation score. Make them to be consistent, and then the opposite is true. I can as well just say the opposite is true, but that will be lazy to do that. The less the number of projects, the lower the last evaluation score. So that is the report. This one will go to our report. So let's make this as correlation analysis, if such like thing exists. Make it a heading. Now, so what does this tell us? Probably the departing employees had less average monthly hours, and they were involved in less number of projects and short stint with the company. So that is probably what is telling us. Let me just add that one here as a note, and you can do that in a notebook using the markup language. So markup is a language for writing .html. So division, which is the title, I'm gonna have class equal to alert. So this one, you just copy it from me, please. Don't be stressed about what I'm doing. I'm just trying to make a nice note of it so that it's blue and tells you that something is happening. So just copy, bear with me. Block alert info that should not be there, and then I'm gonna have bold to bold, then B bold, and then note. So this is just a note to the person reading this notebook. B probably write our words. The departing employees had less average monthly hours, number of projects and short stint in the company. So this is just an assumption, not an assumption, but you are making this bold assumption right now. And then let's close it up. Okay, so now we have our note here well written. So probably the departing employee. So this is what I was aiming to create with the nice black background to give you that extra information. Okay, so let's find out. Let's find this out. I'm literally taking you through this script so that whenever you come back, maybe 3 or 4 months later on, you will be able to know what you are doing. So we do this to find that out, whether the departing employees had less average monthly hours, number of projects and short stint with the company. We're gonna do an average of each of these columns. So we're gonna do average monthly hours for the employees who have exited. So for these employees here, and then compare with the average monthly hours for the employees who have not exited, and see how many have worked more, the ones who have exited or the ones who are still with the company. And then we're going to do the same for the number of projects. We're going to compare that out of the employees who have left, what's the number of or what's the average number of projects they have worked on. So probably they might have worked on many projects or high number of projects, but they have not been promoted, and maybe that is the reason why they have left. Or they might have worked more hours than those employees that are still there, but they have not been promoted. So they think that their input is not well rewarded in the company. Or it might be that maybe they just had a short experience with the company. So that is what you're going to find out in the next section of this tutorial. I think our time is almost up. It's 1 hour. We have done this. So let me just write what we are going to do, and then we can move to the part 2 of this project. So we do this by comparing the average monthly. So this is what we are going to do next. Number of time average monthly hours and number of time spent in the company, and then number of projects for the exiting employees and existing employees. So that is what we are going to do in the next section. So please, once again, if you have not subscribed, please subscribe. If you like the video, give it a thumbs up. Leave a comment if you have a question. If you have got any addition, please leave it in the comment section, and I will endeavor to respond to your comments. Until next time, bye-bye.